Hello Legacy students, Marsh here. So today we're going to look at how to factor a quadratic equation. What you're going to want to have on you, pen or a pencil, that foldable booklet notes that I gave you. You may need a calculator just for simple math, and then you're definitely going to want your thinking cap on today. Quadratics are not very difficult factoring them. You've been doing it for a long time, so this should feel like a refresh video, but just in case not, then you're going to want to focus. Basically knowing how to multiply, basically what we're going to be doing is factoring is undoing multiplication. So multiplying, remember we did the FOIL method, so this particular problem right here ought to have x squared plus 3x minus 3, or x squared plus 2x minus 3 would be my final answer. Same thing with that one. You're going to want your factoring foldable that I gave you in class. Now, open up your top flap. What does it mean to factor? Well, to factor means you're going to find out what was originally multiplied to create the expression. AKA, we undo the multiplication process. Don't consider it division, but it kind of almost is. Basically, you're going to figure out what two things multiplied to give you that original value. So looking at greatest common factoring, this is the first thing you're going to want to complete every single time you start a factoring problem. First of all, the question you're going to be asking yourself is, what is the largest number or variables that can be divided out of each term in the expression? So I got a couple of examples here for us to look at. So that's the question I want to ask myself. What is the largest number and or variables I can divide out? So if I look here, I got 6x squared, 12x, and 18. So the number that is the biggest that can be taken out of each of them would be a 6, right? Well, now I gotta see, can I take a certain number of x's out of each of them? No, no, no. So I cannot, bad fingers, cannot take an x out. So I need to decide if I take this x out, basically I'm going to undistribute it from that problem, aka I'm going to divide each of these by 6. So if I divide 6x squared by 6, I will be left with x squared. Negative 12x divided by 6, that's negative 2x, and then 18 over 6, that is 3. Notice, guys, I could factor that further, but not with GCF. We'll cover that in a little bit here, how to factor that kind of problem. Let's look at the next one here. So what's the largest number of variables and just of the coefficients, the numbers that I can take out? Well, 14 and 7, well, they both share 7, right? Their greatest common number is 7, greatest common factor. And then they both have at least one x, right? This guy has an x, this guy has 4 x's, but I need to find what's common between the two of them, which would be just good old x. So what I'm going to do in this problem is divide both of these by 7x. So 14 divided by 7, that's a 2. And I think there will be 3 x's left. Whoops, lost something. There'll be 3 x's left, because if I take x to the 4th and I divide that by x, technically that's going to cross off 1 x here, so I'll be with 3. 7 divided by 7, or 7 divided by negative 7, that's negative 1, and then the x's will cancel themselves out. Always make sure, if I distribute this back in, you should get what you started with. That's the coolest thing about factoring is if you remultiply, you should get the same answer back. What I want you to do is try the third example. We'll check them over in class when you get back, but try the third example together on your own. See if you can find the GCF in that one. Now, what about group factoring? What you're going to basically do is group into pairs. You're going to factor out the GCF of each group. You're going to factor out what's in common one more time. And that's what we're going to be doing. So let's try this one here. What I'm going to first do is group into pairs. And I want to find out what's the GCF of this particular 2 pair. Well, They both share 2, so I know I'm going to factor out a 2. And they both share, there's 2 x's that they both share, right? This guy's x squared, this guy's x cubed. So I can factor out an x squared, because that's the largest number of x's that they both have. So, looking at what I am ultimately going to have after I factor out 2x squared, looks like I'll have an x plus 6 left behind here. So if I redistribute, I should get back there. What's common between these guys? Looks like a negative 5, right? They both have a negative 5 common. Which, if I factor out a negative 5, aka divide both these by negative 5, I will get x plus 6. So now I need to figure out what's common between this term and that term. Well, they both share this x plus 6, right? So if I factor out an x plus 6 out of each of those terms, I'll be left with a 2x squared, right? Because that would have been gone. And then minus 5. This would be my answer after I factored. Let's try this one. Pair what I got. So I'm going to, looks like 2x squared is the greatest common factor out of this pair. So I have x plus 2 left behind, right? Because 2x squared times x is 2x cubed, 2x squared times 2 is 4x squared. Okay, what's common between x and 2? Well, if there's nothing in common, we can say they share a 1, right? Because everything shares a 1. So if I factor out a 1, you're just going to be left behind with the same stuff. Again, just like last time, I'm going to factor out what's common, which notice, guys, x plus 2 is common between these two terms, which will mean if I factor out x plus 2, I will have 2x squared left behind and a plus 1 left behind as well. What I want you to do is try the last example on this page as well. See if you can get the answer. Like I said, in class we will go over the answers for the ones we didn't do in the video. Let's look at trinomial factoring. How does one do trinomial factoring? So we're going to do the AC method. What you're going to want to first do is take A and multiply it by C. What does that mean? When you have your quadratic equation, you have this ax squared plus bx plus c, right? Well, what you're going to do is take the first number multiplied by the constant in the back. What this will do is allows us to find two numbers that multiply to give us this number, but add to give us b. This allows us to mathematically, without having to guess, figure out how to break this apart. This will allow you to turn this into a 4-term grouping problem, which is not as hard. Let's try a couple of examples, shall we? So what we're going to do is we're going to take the first number here, which is a 1. If it's not there, it's a 1. And we're going to multiply it by our c. So 1 times 6, that's 6. Then I'm going to ask myself, what two numbers multiply to give me 6, but add to give me 7? What numbers make 6? 2 and 3. 6 and 1. Well, and 6 and 1 adds to give me 7, right? So what we're going to do is we're going to take these two numbers that we just found that make that, and we're going to expand that middle term. Just like this. We're going to expand this so it's equal to that 7x, because these two together make 7x. Now, we do exactly what we just did on the last flap. I'm going to factor out an x here. We'll get x plus 6 left behind. These guys share a 1, so I can factor out x plus 6 there as well. Factoring out what's common between this term right here and this term right here, looks like it's an x plus 6. So I'll be left with an x and a plus 1. I'm going to want you to try example 2 for me. So try example 2, and then I'll do example 3 with you. So 3, notice guys, our a is not 1, so we got to be a little bit more careful with this one. We got to go 3 times negative 2, which will give me a negative 6. So I need numbers that multiply to give me negative 6, but add to give me this positive 1 in the middle. So numbers that make 6, well, that would be like 3 and 2, 6 and 1, but these would make positive 6. So 3 and negative 2 would make a 1, and those two multiplied do make me negative 6. So 3 and negative 2 looks like it's my best bet. So if I expand my middle term, got plus 3x minus 2x minus 2. So basically I just expanded the middle to make it into there. Let's factor out from these guys. They share, looks like a 3x. So I'd be x plus 1 left behind, right? If I divide this by 3x and that one by 3x. What do these guys share? Negative 2 it looks like. So divide this by negative 2, be left with x. Divide negative 2 by negative 2, that is a 1. Looks like they share an x plus 1. So if I break it into its separate pieces, I will get 3x minus 2 times x plus 1. Now, coolest thing about factoring, guys, honestly, coolest thing, this remultiplies to give you that. You can always, always, always check to make sure you got the right answer when you're factoring. And I recommend it. It's the coolest thing ever. Make sure you got the right answer. Last kind of factoring here. Difference of perfect squares. This is when you have only 2 terms. So one of them was for 4 terms, I was grouping. One of them's for 3 terms, this is for 2 terms. Now, when you're starting this one has a couple of catches you need to make sure of. If you are checking for difference of perfect squares, you need to first make sure you have a difference, a perfect square, and then you can use it to factor in 2 factors. One of them will be positive, one of them will be negative. Let's try a couple. So first thing I want to make sure is these 2 pieces, do I have a difference? Yes. Subtraction, right? Are these 2 the same? Are they both perfect squares? Yeah, that one's a perfect square, and so is that one, right? So I'm going to be able to break it into 2 factors, and they're going to look exactly the same, except one's going to be a plus and one's going to be a minus. Basically, this is going to be the same as here. This is going to be the same as here. So something times something has to give me x squared. Well, that would be an x and an x, right? Something times something has to give me 49. Well, that would be 7 and 7. Notice, guys, how do I know this works? Because you could use AC method if you wanted, and you could break it into its 4 pieces, you could do your grouping, you could do that. But I know this works because I need to have a 0x in the middle, which if I FOIL this back out, I'll get negative 7x plus 7x, which simplifies to 0. So that's why I know I can do this quick jump if they're both perfect squares. So taking a look at example 2 here. These guys have the same number. There's subtraction. They're both perfect squares. So I can kind of break it into its 2 pieces, one with a plus, one with a minus. What two things would make 4x squared? What times itself would be 4x squared? Well, a 2x and a 2x, right? That would make 4x squared. And then what times itself will make 9? Well, that would be a 3 and a 3, right? These two guys multiplied together, that should make 4x squared minus 9. So I'll get a negative 6x and a positive 6x if I break it. Let's factor out, ooh, this guy looks a little different, but there is subtraction, right? And they're both perfect squares, so same thing still applies, one with a plus, one with a minus. Two numbers that make 81. One number multiplied by itself makes 81. Well, that would be 9, right? W squared, that would be a W and a W. Let's try one more here, and then I'm going to have you guys do the last three on your own. So this one, both perfect squares, and there is a subtraction. So I can break it into its two pieces, one with a plus, one with a minus. Looks like it'll be a 4x and a 4x, right? Because 16, 4 times 4 is 16. And then a 5 and a 5. Notice, guys, these are pretty easy. They're easy to identify. Do not get lost. Be very, very careful and make sure you pay attention to that they're both perfect squares. If they're not, this is not the method for you. This will be what would be considered not factorable. And that's the end of this video. Complete the rest of those problems and we'll go over the answers in class. See you later, Savers.